Okay, our next idea is factoring trinomials in the form x squared plus bx plus c, or equivalently, you can think about like ax squared plus bx plus c, but a is 1, so it doesn't look like it's there. The same technique applies when you have something like x squared plus bxy plus cy squared. Exactly the same trick. So let's start with x squared plus 3x plus 2, and I'm going to briefly talk you through a few different methods. The first one that people tend to teach is decomposition. So you take this x term and you break it into two pieces. How exactly break it up into two pieces? You want to somehow make a binomial common factor on the way. So for example, let's say I notice that 3 is 2 plus 1. So if I do 2x and x, I might notice that you have a 1 to 2 ratio in both of these, so that's should give you some kind of common factor. The first pair you can factor in x to get x plus 2 left over. And the second pair, well, it doesn't look like you factor anything, but that means you can always factor out a 1. So in that case, you can see clearly now there is an x plus 2 common factor, and the remaining factor is x plus 1. Now, I don't like this method personally because it gets cumbersome when you have larger numbers involved. So here's another way that you can think about it, which ultimately all the methods here are guess and check. So you'll notice that how do you get this 3? Well, you'll notice that 2x 2x times 1x, these two pairs are what make the 3. You'll also notice that the x squared comes from this product of the x terms, and the 2 comes from this product of those two constants. So here's another way, which is basically guess and check. So we know it's going to be two factors like this. We know that x squared is probably going to be x times x, so we're going to put that here. And we know that 2 is going to be 2 times 1, so it's going to be, let's say, 2 times 1 like this. And then we're going to check, does the middle term work? So you'll notice 2 times x is 2x. X times 1 is 1x. And that does add up to the middle term, so that means that's the correct factoring. Okay. Finally, one thing that you might notice is that when you, in the special case that a is equal to 1, so when the coefficient of x squared is 1, you can think about, you just factor the constant term, and then you try to find a pair of factors that adds up to 3. So this is 1 times 2, but 1 plus 2 is equal to 3, so that's going to tell you it's x plus 1, x plus 2. Okay, let's do the next example. So we have x squared plus 7xy plus 10y squared. I'm not going to do the decomposition this time. We're going to skip to the other guess and check method. So we know that x squared is most likely going to come from x times x. Let's put that in. And 10y squared, well, imagine 10 could be 1 times 10, or it could be 2 times 5. So we're going to try those out. So let's say our first guess is 1y and 10y. So when you multiply those, you get 10y squared. Now you're going to check whether that middle term works. So you get 1y times x, which is xy. And you get x times 10y, which is 10xy. And you'll see that's 11xy. That's not what you wanted. You want 7xy. So this cannot be the correct guess. So let's try again. So let's try with 2y and 5y. You'll notice you get 2xy from this product and 5xy from this product. And that does make 7xy, so that means this one is correct. Finally, you'll notice that when a is 1, you can use that shortcut where you just look at the factors of 10 and look at which ones add up to the middle term, which is 7. 2 plus 5 is 7, so that was the correct choice. Okay, let's keep going. The third example is going to be n squared minus 10n plus 16. So again, we're going to think about how you could break up 16. That could be 1 times 16, 2 times 8, or 4 times 4. So you'll notice right away that 2 plus 8 does add up to 10, so that might be our solution. Let me write that down just so you see what I mean. Let's guess you have n from n squared, and 16 you had 2 and 8. Okay, so if you do this, you'll see that's 2n plus 8n, which is 10n. That's almost correct, except it's positive, but we really wanted negative 10n. So we're going to remember that if you multiply two negative numbers, that also gives you a positive number. So let's try negative 2 and negative 8 instead. So 2, 8, but both are negative. So you can check now, negative 2n, negative 8n, put those together, you get negative 10n, so this is the correct factoring. Okay, last of these examples, we have a squared minus 3ab minus 18b squared. So if we think about 18, you could break into 1 and 18, 2 and 9, 3 and 6. But you'll notice that it's actually negative 18. So one of these has to be negative. So if I want to be thorough and write out all the choices, I can think about it could be negative 1, negative 2, negative 3, and positive 18, 9, 6. Or maybe it's switched. Okay, those are all of our choices. And again, we want to add the two factors to get the middle one. So you'll notice that 3 and negative 6, that one works. That gives you negative 3. Let's write that down. So from a squared, you're going to get a and a. From negative 18b squared, you're going to get 3b and negative 6b. And again, just to check, you can say that's 3ab times negative 6ab. That is our middle term, negative 3ab, so this is correct.